Well, it's time once again to take a look at what's new in Agilent ESOF's Advanced Design System, this time released 2006. One of the reasons you use EDA software is to complete your designs to get to the finish line faster. At Agilent ESOF, we help you do this by making each release of ADS faster and more efficient. But there's another way to finish faster, and that is to start closer to the finish line. Several new tools are now available in ADS as a result of our acquisition of Eagle Aerolonics that give you a head start in the design process. I'll quickly demonstrate these unique capabilities, then take you on a whirlwind tour of the rest of what's new in this release. Let's get started so we can finish faster. The Tools menu in ADS now has two new choices. I'll start Spectrasys and open this two-stage down converter. Spectrasys is a spectral domain RF architecture simulator. We'll be looking at the output of the first IF of this down converter. The results from every other simulator would produce one composite spectrum, the sum of all the traces you see here. But Spectrasys actually keeps the responses separate, enabling you to see where the contributions or errors are coming from. This signal is the desired signal. You can see its frequency, magnitude, and path through the system, starting with the wireless LAN source, through the filter, mixer, filter, continuing on to the output. Here's a distortion product that folds back into the main signal that takes this path and is actually a harmonic that is poorly loaded and gets reflected back as a feed-through term to the output. This tracing of the individual contributions is unique to Spectrasys. You just won't find this in any other simulators, budget analysis tools, or spreadsheets. This root cause analysis helps you to understand and troubleshoot a design before you begin implementation. A few of these system components are actually circuit-level schematics in Spectrasys. This pre-select filter, for example, is implemented in microstrip, and this bandpass filter was done as a lumped element filter. When I export this workbench to ADS, we see these various subcircuits as well as the overall block diagram. So we're done in Spectrasys and we've exported the workbench. Now let's use it in a system schematic in ADS. The down converter from Spectrasys is now this subcomponent here. It is stimulated with this wireless LAN signal. The output is demodulated and tested for system-level parameters such as packet error rate or EVM. Note that we are looking at the performance of this fully implemented block diagram, not just system blocks. For example, this bandpass filter is implemented as a momentum co-simulation with real surface mount parts, so the system-level simulation accounts for those physical parasitics. Spectrasys is a great companion tool to ADS. With it, you can experiment with architectures and iterate very quickly. With ADS, you can do a bottoms-up verification of the implementation. In this example, we added a DSP layer on top of our original analog layer and used it to create realistic signals to exercise the design. Spectrasys and ADS make a powerful combination. Well, that's a quick look at Spectrasys. Let's move on and take a look at some of the synthesis tools. This time from the Tools menu, I'll launch the synthesis tools. I can then choose which of these powerful design automation tools I want to use. Let's synthesize a passive filter. The synthesis tool is launched. I can choose the type of filter and step through the various shapes for the filter. With a button click, I can make this a differential circuit and see the resulting change in the topology. The specs for the filter are entered here. Once I have the filter I want, I save the design and then export the schematic to ADS. I can export the schematic and a test bench. The filter is now ready for use in ADS. Synthesis tools give you a head start in the design process because you no longer need to consult the resident specialist or learn arcane design information. Your designs are completed quicker, with fewer errors, and improved repeatability. There's even a tool to help you pick a spur-free IF band for a transmitter or receiver design. It's called the WhatIF Frequency Planner. I can select the number of mixers in my system, the RF input frequency of each mixer, and the RF and IF bandwidth. When I click Apply, this display shows the spur-free IF bands available across the frequency range. Again, I save this design and export it to ADS. With WhatIF, you can accomplish in a matter of minutes what could take days or weeks to accomplish in the past, and now it's all available in the Advanced Design System. For release 2006, access to Spectrasys, Synthesis, and WhatIF is the big news, but there's much more to this release. One new feature I'd like to highlight is our ability to connect users to real-time problem solving through the Agilent Knowledge Center. Let me illustrate this increased level of support by simulating this simple circuit with a frequency-dependent resistor. When I simulate, I get an error message, and you see that my use of frequency dependence is not allowed on this lumped element. Now what do? Go down the hall and ask the ADS guru for help or open the manual? Well, now you can get immediate help 24 hours a day, 7 days a week. Here's how. By clicking this button, I'm taken to the Knowledge Center. Here I get an explanation as to why a resistor can't be frequency dependent. This entry here shows me how to simulate frequency dependent lumped elements. It even has a downloadable example I can use. With over 10,000 users of the Knowledge Center worldwide, chances are high that someone on the planet has already solved a problem you may have. This is a great new feature. And in the spirit of racing to the finish, here are 9 more new features in rapid succession. Number 9. The harmonic balance simulator has been enhanced to do an even better job of simulating divider circuits. This circuit has a divide ratio of 128, contains over 200 nonlinear devices, over 800 linear devices, and it's solved in under 20 minutes. Number 8. We've broadened our support of 64-bit platforms. Now, not only our momentum simulator, but also our circuit and Ptolemy simulators support these 64-bit platforms. Number 7. ADS now has peak, valley, minimum, and maximum marker functions, and the marker will track while tuning. Number 6. The ADS Ptolemy System Simulator can handle designs with multiple data rates much more efficiently, which is particularly important with the newer emerging wireless standards. 4 of these new wireless standards are now available from Agilent ESOF, including Mobile WiMAX, High-Speed Up and Down Packet Access, 802.11n, and WiMedia Wireless Libraries. Number 5. With the new Import Wizard, ADS automatically configures your MATLAB and System C blocks for use in the ADS Ptolemy System Simulator. Now you can easily verify system architectures with DSP algorithms and real-world RF effects. Number 4. The Momentum 3D Planar Electromagnetic Simulator now accounts for full 3D current effects in vias by modeling both vertical and horizontal currents. Or for an array of vias like you'd have in a large RFIC package, vias can be modeled as lumped elements for faster simulations. Number 3. Several processes in layout have been sped up significantly. This is a ball grid array package with over 2,400 items. You can now check what traces are connected to each other with the Layout Connectivity tool with no speed penalty. Number 2. Layout editing functions are also much faster. If I wanted to work on just a section of this layout to do an EM simulation, for example, I could use the crop function by selecting all items, then selecting crop and highlighting only the section of the layout I want. This function now operates near instantaneously even on circuits of this size. And number 1. Finally, 2006 provides free access to our SPICE Netlist Translator and IFF Translator products. Supported customers can more easily connect the ADS platform into industry-standard design flows. That should give you a good picture of the broad range of improvements we've made to the Advanced Design System. There's more, of course, but we've reached the finish line for this video. You'll now be taken to a web page where you can get more details on the features in ADS 2006 that help you start closer to the finish line. As always, thanks for watching.